Hi guys, in this video, let's discuss about solving right spherical triangle. First, let's define what is spherical trigonometry. It's a branch of spherical geometry which deals with triangles drawn on the sphere. There are 5 properties of spherical triangle. Number 1, the sum of the sides of spherical triangle is less than 390 degrees. Number 2, the sum of the spherical angle is greater than 180 degrees and less than 540 degrees. Number 3, if two angles of a spherical triangle are equal, the opposite sides are equal. Number 4, if one angle of a spherical triangle is greater than one another, the side opposite the greater angle is greater than the side opposite the less than angle are conversely. Then lastly, the sides and angles of any spherical triangle are respectively the supplements of the angles and sides of the polar triangle. The figure shows the solution of right spherical triangle. There are 10 rules or formulas in solving the right spherical triangle. Rule number 1, sin A is equal to sin C times sin A. Rule number 2, sin B is equal to sin C times sin B. Rule number 3, tan A is equal to sin B times tan A. Rule number 4, tan B is equal to sin A times tan B. Rule number 5, tan A is equal to tan C times cos B. Rule number 6, tan B is equal to tan C times cos A. Rule number 7, cos C is equal to cos A times cos B. Rule number 8, cos C is equal to cotangent A times cotangent B. Rule number 9, cosine A is equal to cosine A times cosine B. Then lastly, rule number 10, cosine B is equal to cosine B times sine A. Napier's rules. 1. The sine of an angle is equal to the product of cosines of the opposite two angles. Number 2. The sine of an angle is equal to the product of tangents of the two adjacent angles. There are 6 types of cases on spherical triangle. Case 1, given the two legs A and B of the spherical triangle ABC right-angled at C. Case 2, given the two oblique angles A and B of the spherical triangle ABC right-angled at C. Case 3, given the hypotenuse C and either leg or B. Case 4, given the hypotenuse C and either angle A and B. Case 5, given one leg A and its adjacent angle B. Then lastly, case 6, given one leg A and its opposite angle B. Example: solve the spherical triangle ABC right-angled at C, given A is equal to 48 degrees 24 minutes and B is equal to 59 degrees and 38 minutes. Solution: to find C, we use the rule number 7, which is cosine C is equal to cosine A times cosine B. So we have cosine C is equal to cosine E is equal to 48 degrees 24 minutes times cosine B is equal to 59 degree and 38 minutes. So we have cosine C is equal to cos 48 degrees 24 minute times cosine of 59 degrees of 38 minutes. The result is 70 degree and 23 minutes and 20 seconds. Then, to find A, we use the formula of rule number 3, which is that tangent A is equal to sine B times tangent A. So we have tangent A is equal to tan A over sine B. So we have the tan A is equal to tan of 48 degree and 24 minute over sine of 59 degree and 38 minute. Then let's solve. We have A is equal to inverse tan of 48 degree and 24 minutes over 59 degree and 38 minutes. Then simplify. The result is A is equal to 52 degree and 32 minutes and 48 seconds. Then lastly, we solve the B. We use the formula rule number 4, which is tangent B is equal to sine A times tangent B. So we have tangent B is equal to tan B over sine A. So substitute. We have the tangent B is 59 degree and 38 minutes, and sine A is equal to 48 degree and 24 minutes. So we have tangent B is equal to tan of 59 degrees and 38 minutes over sine of 48 degrees and 24 minutes. Then solve. We have B is equal to inverse of tan of 59 degrees and 38 minutes over sine of 48 degrees and 24 minutes. Then simplify. We have the result of B is equal to 66 degrees and 20 minutes and 22 seconds.